thank you very much for your interest. Thanks for joining us. We are, as I've said, we are going to give you an introduction to Apache Flink and also some demo and later on some hands-on. And I hope you will enjoy it. So a little bit about us first. And then, by the way, Volker's not here anymore, but it was a really nice talk, I think, to get an idea about when to use what program and to reason about when we really have big data and when we need Flink or Hadoop or just maybe MATLAB. So a little bit about us. My name is Max, and with me is Ufuk, hey. and we are both Apache Flink committers. Actually, we are not the only committers that are in this room right now. So if you're Apache Flink committer, please stand up. Please, yes. So we have Vasya here, we have Paz, we have Nicholas, we have Gyula, and Theo is also here. He also worked on Flink, right? So yeah, that would be really come in very handy when we do the hands-on later on. So you can also ask not only us, but also the other Apache Flink committers. Yes, as I've mentioned, we are working at Data Artisans, and we are fully dedicated to developing Apache Flink. So the goal of this talk is really just to get you started using Flink. Who of you has already used Flink before? Okay, that's maybe 1/3. So maybe also those people will learn something new today. So first, we'd like to give you an overview of Apache Flink, just to let you know like how it works roughly. And then we talk a bit about how it works internally. We will give you an idea of the basic APIs, which will help you to do the hands-on later on. And then we will do the exercises and give you a demo and show you some advanced features. For the exercises, we have a website, which is here on the board. This is the shortened link. Yeah, it's also. Or you can use this link here on the slides as well.
The slides are available on the web page and comments, so they can also copy and paste from.
Right, the slides are also on the web page, but here you can also find the exercises.
The exercises only here, not on the.
You can find here the slides and the exercises, and the slides are also on the summer school web page if you, prefer a PDF. Right. So, what happened? What is going on with Apache Flink? Because not too long ago, not so many people talked about Apache Flink, and the reason for that is not that it was just created, but it actually got a lot of attention because it also entered the Apache Software Foundation, and just 1 year ago, it was the core basically hasn't really changed, but it was a much smaller project with just the dataset API for batch processing. And just 1 year later, we already have a dedicated streaming API and a bunch of libraries, which we'll talk about later. So a lot of things happened. And that's the result of very hard work of a lot of contributors. And we can see here that it's also reflected in the contribution graph, which is derived from the Git repository. The project started very early in 2008, 2009. And you can see that now we have, today we have over 150 contributors already in total. And it's one of the most active big data projects. Some of you might not really know what Apache is, or probably heard it before, but it's really a kind of philosophy, a kind of way of developing software in an open way. And some people like to call it the Apache way. The Apache Software Foundation is really an independent non-profit organization based in the US. And it is really the process of Apache is really consensus-based and tries to have low hierarchies and tries to communicate everything open and public. So while we are working at Data Artisans on Flink, we also try to do it the Apache way and communicate openly. And that's also the key to success, because we get external contributions, and yeah, that helps to improve Flink. So because we talked about Hadoop yesterday, we want to give you, before we really start, an idea what role Flink plays in this big data stack, which are mostly Apache project, but not only. So of course, here in the API side, we can integrate Hadoop input and output formats, but also existing map and reducer functions. We can reuse them, so that's really handy. And for concerning data access, of course, we rely. We can use HDFS, but we're not dependent on it, and a bunch of more ways to access data in the cloud. And on the deployment side, you can also run Apache Flink directly, but also on top of Hadoop Yarn or Apache Tez, or in some other cloud environments. So, having said that, like, what really is Apache Flink? And if you break it down and try to simplify it as much as possible, you could call Apache Flink a stream processor, with which you can realize a lot of applications. So at its heart, we have the streaming data flow runtime, which really interprets all the programs you write as a data flow graph and runs it in a distributed streaming fashion. Yes. And what can I do with Flink apart from these basic concepts, which you don't have to think about a lot most of the time? We have very convenient APIs, and they're all based around the basic concept of bootstrapping from a source, a data stream or a data set, and then applying various operations like a map, reduce, or a join, and these lead you to to a data set or data stream. And once you output your data to a sink, you have a complete Flink program. So it's basically these 3 steps. And what are like very simplified applications that you can realize with this data stream or data set API? Well, we've seen the MapReduce example, which is here depicted very simplified, where we, for example, bootstraps a triangles data set from a table where we store the base and the height of a triangle, and then map them to rectangles, sum up all the areas of the rectangles, and write out the area of the square we get. And on the streaming side, we have, for example, a live stock feed where we get in the current stock prices of stocks like Microsoft, Google, and we want to alert, for example, if the Microsoft stock increases by a certain threshold, or we want to know about like what's going on in the stock market, summing up all the stocks every 10 seconds, and also alert if some threshold exceeded. Like this. There's some basically infinite possibilities, but just to give you a basic idea, I wanted to have these 2 examples. What is the difference between streaming and batch? Well, really simplified, if we have these 3 categories: input, data transfer, and latency. We have, of course, on the streaming side, possibly infinite input, and the data goes through the program in a pipelined way, so there's no materializing of the results between the operators, but the data goes through. And generally, it's nice to have a low latency for streaming. I mean, it doesn't have to be low, but it should be, because you want results fast, and you want to ideally run your streaming applications in real time. on the batch side, you have a file, for example, in HDFS, it's finite source, and in Flink, we can usually in batch you execute blocking, but in Flink we can also pipeline batch programs, but the latency you get is usually high because you have to process usually all the data first to get some result. And the really cool thing about Apache Flink and also other projects is that if you declare your operations, your program, your big data program in those APIs or in a library, then you can, because these operations which are supported can be parallelized, you can parallelize your program as well to, by setting we call it parallelism, to basically arbitrary amount of machines. And not only that, of course, you can also write very complex programs which have multiple inputs and outputs and bootstrap from several sources and go to several things. And this is, for example, a real, I mean, it's very blurry, you cannot see anything, but this is a real job graph we ran on top of Apache Flink for some of our customers which tried out Flink. So if we look at the system, we want to know what's the architecture of system, how does it work internally, and to give you an overview first about the architecture, I want to show you that it's really simple and it's not so different from many other systems. So we have the client, which is responsible for submitting programs and writing programs, and then we have the job manager, which is just another name for the master in Flink. And the job manager talks with the client and receives the data flow graph that we want to execute, and talks with the task manager, which are basically the workers, and lets them execute the Flink program. So if we look at it a little bit more in detail, the client is responsible for optimization and for deriving what we call the job graph, which is the data flow. It's extracted from your program, and yes, passes this to the job manager and retrieves the result. And the job manager is, as I said, the master. From the job graph, it generates the execution graph, which is basically another graph which contains all the state of an execution of your program, and job manager makes sure that it assigns the task to the task managers and handles failovers in case the task manager dies, and keeps track of the whole execution. The task managers, as I mentioned, they receive tasks. I think this is a bit different from what tasks are referred to in Hadoop, but tasks are pretty much parallel instances of an operation you specified in the API. And these tasks run in what we call task slots. And maybe not entirely intuitive thing in Flink is that several tasks can run in one task slot, because preferably we execute programs in a pipeline, so in a streaming way. That means we have to make it possible for operators to pass on results directly within a task slot to another operator. And how does this look when we put all this together? So we have your program, you write it in your favorite IDE, and then the client phase, which we also call prefired phase, it extracts the types, figures out how to efficiently execute your program, checks your data and efficient execution strategies, and optimizes them. It generates the data flow graph, hands it on to the job manager. The job manager takes care of the whole execution and the scheduling, and the task managers do the actual work. Okay, that was a really rough overview of how Flink's architecture looks like. Now I want to show you a bit more what happens on the task manager side, so where the actual computation of the results happen. So I mentioned that a program is basically, so the job, what we call the job graph, is basically a graph, a direct acyclic graph of operators. And operators in Flink can compute, but also they can hold state in the case of streaming. And what happens in this after we generate the execution graph at the job manager is that we have a source here, an operation, and followed after that operation we always result with an intermediate data set, which is really just a logical way to represent a result of a computation. So we will see what that means later on. But this abstraction is very powerful, and we can realize lots of different behaviors at runtime with this abstraction. So I hope it's not too complicated, but I'm going to explain it in detail. So I wanted to show you what really happens at runtime when we execute a job graph, which is turned into an execution graph at the job manager. So as I told you, the job manager is responsible for the whole for managing the whole execution. So what it will do first, it will bring up tasks at the task managers, and as I told you, those tasks can be not only, and this is a task slot here, so it can not only be one task but several, like for instance here a map and a reducer in one task slot. And once it brought up this these two mappers on two different task managers, the mapper will report to the job manager when an intermediate result is available. And the job manager will then proceed and tell the next operator, bring up the next operator, or tell it to fetch the data, and the operator will get the data from either, in this case, locally from this result partition, that's what we call the partial results, or via the network, for example. Yes, and
from R2, like asking over the network.
Right. Here it goes over the network. And in the case of, for example, a simple map reduce job or a batch job, this can be blocking. So we have to materialize the whole result partition first. Or if we have, for example, a streaming job, the execution, we can also do a map reduce job in streaming. The execution looks basically the same, but we use the pipelined result partition, which means that we that immediately once the result partition, once data is available for the result partition, we notify the job manager, and the next task can consume the results. That lets us pipe the data through the system in a streaming way. Yeah, and of course you could also do that differently, and there are systems who do it differently. You don't have to have this flexible runtime, streaming runtime. You can just execute, discretize basically your streams into several jobs and execute those, and have a blocking result for every job, which you hand over to the next job. That's also a way to do it, but in Flink this is supported natively. So we like to think about batch as a special case of streaming. So, and here's a little comparison to show you. In batch we have a finite input file, in streaming infinite, and if you think about this, it's really just a generalization streaming. If you can handle infinite streams, you can also figure out like when to stop in case of a finite stream. And in streaming we have this concept called windows, which lets you basically define a time span or some number of elements which you like to aggregate first and then perform some computation on. In case of batch, this is just a global window, which is just one window, and in Stream we have several. And I mentioned already we have pipelined data exchange and streaming. While we have a batch, we can actually use both. Okay, and now that we have explained the runtime, I want to show you that we can realize very, very different applications on top of this runtime. Of course, we can do stream processing, we can do batch processing, but we also have, and we will cover that in the advanced section, we also have some very efficient ways to run machine learning algorithms at scale. For example, also supporting iterations and delta iterations, which I did not cover here, but it's basically allowing cycles here in the data flow graph. And also, we can handle very efficiently graph analysis. And these are the main libraries built on top now, but there are always new coming up. There are definitely more applications that you could do. So, now that I did all the talking, you might have got bored and you asked yourself, like, so it's interesting, but does it really work? And we wanted to show you that we can do a demo for the streaming case, which demonstrates a nice use case.
Yeah, the idea is that Max does a demo now, then he talks about the API for you guys as a preparation for the exercise, and then we have roughly an hour for the hands-on session, and then after lunch break we either continue with the hands-on or with the advanced introduction. So this we can decide on the spot. So what Max is going to do now is he is going to live feed Wikipedia edits into Flink. So there's this IRC channel, it's called Wikipedia something, where all the edits to Wikipedia are live mirrored. So Max is going to set up a system to feed this data into another system called Kafka. And Kafka is basically the HDFS of streaming. So we store the live edit somewhere on the system. So it's rather small, by the way.
Oh, it's small, yeah. Let me see, can I increase the size? Yes.
Yeah.
So, nice. Yeah, so basically what I did, I started Yarn and Kafka, and now we read from this IRC channel and parse the strings, the JSON strings from IRC channel into Kafka, and we can verify this works by reading from the Kafka topic. So we see now we get a bunch of JSON objects, strings that contain the channel, which is either actually only Wikipedia or the Wiktionary and only the English one, and the user and some timestamp and number of lines modified. Yeah.
So this is not Flink yet. This is just like reading the data in.
Yeah, but this confirms we have the data. So I will stop consuming from Kafka and switch to my IDE.
Yeah, exactly. This is also what we're going to do later on today. So get used to it.
So
which IDE you're using?
I'm using IntelliJ, yes.
IntelliJ.
Yeah.
Yeah.
So
And this is a Scala program.
it's a Scala program, yes, but it could also be done in Java. And actually, the API I present later on will be in Java because I think more people are familiar with that.
Yeah, and don't get confused. This is more like a preview. So
Yeah. So what do we have here? We have what we call the execution environment. In this case, a stream execution environment, which is a kind of context for all of our execution, and we also bootstrap the source from it. In this case, a Kafka source, which reads from this Kafka topic, Wikipedia raw. And once we receive this, we receive messages. We apply, which are the strings. We apply a flat map, and we have written a JSON extractor which converts the string to a Java object, which we have here, So it contains a bunch of fields like
It's
which are
quite
contained
small.
there. Oh, it's too small. So like the channel and the time and the user. Okay, we don't have to worry about that. Let's first see if that works. So basically we do the same as I just did from the command line. It's too small.
Can you make it bigger?
I don't know how.
It's okay.
It's okay, but what you see is that in the beginning it was very fast. It was basically catching up with the historic data, processing all the stuff from the time Max started this consumer. And now it actually has caught up with real time, and you see that the processing is slower because data is coming in slower.
That's horrible.
Yeah.
How do you increase the size? Okay.
Okay, then, yeah, as a next step, if you're not just interested in the raw data, you would apply some further transformations. For example,
Can we
Better.
that's better, huh?
Yeah, you can see now.
Okay, now we cannot see that much, but okay. Okay.
yeah, it's also not that important, I guess.
So let me stop that. And now, whoa. Now we can, now we have the data, we're reading data from Kafka, we can apply some more operations.
So the data now are transformed into certain objects or what?
Right, these are objects, right? This edit object which was printed there.
So now you have a stream of edit objects.
Right, so I can
Just to
apply a map operation, for example, which is really nice in Scala because it has this nice ABI. So I get this edit object, and I might want to just, because we have a lot of different fields here on this object, like div UL, we're not really interested into that. So we just select the channel, the username, and print this again. So see how that looks like. So as expected, now we have only channel and the username. And we might now want to count for a certain time span how many edits a user makes. So there are actually some bots out there which automatically process Wikipedia entries, like clean them up and do some, for example, for verbs, do some change them, like conjugate them. So we might want to group these edits every 5 seconds. And once we have grouped them, we might want to sum up the number of edits. So and how do you do that in MapReduce? Of course, you have to add some kind of a 1 here, so you can sum it up later on. There's also ways to do it differently, but we do it here like this now. So which field do I have to sum up? Sum up the third field, which starts with 0, so it's 2 here. And
which field to sum? That's
right. So yeah, and after that, to get the actual object which are contained in the window, we have to apply the flatten operation. You don't have to worry about that. So now we have to wait 5 seconds. And we see, for example, that there's this Betty bot that does a lot of edits. I don't know, maybe it's just spam, I don't know. But there are also some maybe normal users who have written some scripts to manipulate Wikipedia. Right. So what I wanted to show you now is that we can actually integrate Flink into a streaming pipeline, which means we cannot only read from a source, for example Kafka, but we can also write back. So what we do now is to, of course we could, for example, also apply a filter to filter out only like very high number of edits. Okay, but to feed this data back is we apply another map operation, which actually just converts the whole tuple, this 2-tuple we have, into a string. And then we write it, we not only print it, but we write it back to a new Kafka sync, new Kafka topic, which we call Flink output. And if we do that, we still print here, but we're not interested into that anymore because okay. Problem. Because we can now use Kafka to read from this topic. So it's called Flink output. And we will see that we now used Flink to create some kind of streaming pipeline where we receive input and write to an output again.
And the idea is that another system might then catch up with this data.
So it's like it's doing some data cleaning of a lot of
Exactly.
stream that's coming in and producing another stream that's stored now that people can use it in different.
So this was a rather toy example, of course, but you could also do like more complex processing at this point. Yeah, any question up to this point?
You know what the fault tolerance for the streaming it?
It's a very interesting question, and we get to that in the advanced section actually.
Yeah, one
So-
section or list.
Or exactly, or even more in detail on Friday by Paris and Gula. That's a very good question. But it supports fault tolerance, so much to say, and exactly one semantics. Is there another question, or no? Okay. Okay, then I guess we can continue with the hands-on part by introducing the API. So also maybe let's have a look at the website.
Yeah.
So this is where you get the exercises and also some instructions on how to set up your environment. It's again too small.
Again too small.
So Amir, you have already a virtual machine set up. Can you,
Yes.
would you just interact and say?
Exactly, you can.
So there are two possibilities. So I sent you, actually I put,
It's not-
a link
It's
to the
what-
virtual machine that all the.
It's not the.
That's what you sent me.
Or you can install the packages locally on your machine. So it's up to you. How
Yeah, but you have done that already, right?
we have both options, yeah.
I mean,
I hope you have downloaded them. I sent you an email before, so you can download it from the.
They have already done.
Yes. And
Okay.
if you haven't downloaded, I have on the flash disk, USB disk if you want. Yeah. So you can find the instruction also on the site.
yeah. So, yeah, this is a general intro. You find the slides also here online and on the summer school page. But there's also this point which explains how you can set up the environment for the hands-on session in half an hour. So it also builds on this visual image you can use. So I would ask you to clone this repository. Should work fine with the interconnection here, and import it into the IDE. And to make sure that everything is working, you can run a WordCount example from the IDE, and yeah, to confirm that everything is working as expected. And then afterwards, we'll get to the exercise, and the goal is that we do a little bit fancier word count example, which we call mail count, but we'll get to that. So if you want, you can also already have a look while Max introduces the API. Yeah.
Okay, for the example, we thought it would be nice to give you only introduction to the DataSet API because we cannot really cover everything today, but streaming is also covered later on Saturday by Gula and Paris. So yeah, we are now on top of the Dataflow runtime. We will look at the DataSet API. the APIs are, for example, here in Scala, are not very different. And what is really different is, so the operations are very similar, like a flat map or map or reduce. What is different is the special streaming semantics, like the windowing. Yes, and now don't get confused. This is now Java. Looks very bulky as always, but this is the basic word count in Flink, in the Flink Java API. And I want to show you the steps how to get from bootstrapping your sources to actually running such a program.
If you wish. If you wish.
Yeah. Okay, thanks. Yes. So we have at first always the execution environment, which helps you to bootstrap your whole program, and also later on it automatically determines whether you run this locally or in a cluster environment. Then we have what we call a source. So in this case, a text file. And we get a data set, which is of type string. In Flink, you always specify the types. In Scala, they're actually inferred, but they're always there. And that's really nice because we can execute optimized strategies for dealing with these data types, and also it keeps your program type safe. So once you're in this pre-fight phase, which I showed earlier, you will always notice when types don't match and your program is actually not able to execute. So then you apply operations like fretmat, group by, and reduce group. We'll go over these later. And these can be user-defined functions, which can be any kind of, like this case, a tokenizer and a summation, can be any kind of function. And in the end, you write out your data set to some source. Here it is a CSV file. And don't forget to execute, because all these operations by default, if they don't require execution, then they will just lazily do nothing until we call execute on the execution environment. So, and yeah, as I said, here the user-defined functions, they always implement an interface. Like the flat map function, they have the input and the output type specified for checking types. And yeah, in this case, it's flat map, which gets an input value, and a collector, which lets you emit multiple objects if you want, or just, in this case, we emit all the tokens. Yes, and the reducer is also follows the same logic. Also, we have this, for example, group reduce interface. We also have the map, the Hadoop map reduce style reduce interface, and we have the types. In this case, we get the whole values as a iterable inside the function, so we can iterate over the whole input and produce the output with a call to the collector. So does that make sense? Do you have any questions? Yes? Sorry.
Can you explain about the execution environment?
Okay. What do you want to know about the execution environment?
You just wrote the get execution environment. What does it mean?
Yeah. Well, as I only briefly mentioned, is this get execution environment. Like you can also explicitly create a local execution environment or remote execution environment if you want to have control over it. But by default, this automatically determines like if you actually now run your program inside in the IDE, or you submit it to the cluster via the command line interface. So, and yeah, then it executes differently. And yeah.
How do you distribute the code of UDS to the task managers? Do you like transfer bytecode?
Yeah, we transfer. Yeah, we have to transfer bytecode. Otherwise, the task we have to get the classes somewhere to the somehow to the task manager. Otherwise, they will not find the class. And we have a special what we call the blob cache, blob manager, with a special sort of way of distributing them. And we could also that way we are also independent of HDFS. But we could also put them into HDFS, for example.
But you can put them
Yeah, the client
Yeah.
submits them to the job manager, and the job manager takes care per job to distribute the jars and cache them.
Yeah.
So if you reuse jars over multiple jobs, you won't have to like redistribute every time.
Okay, so a little bit about the concepts after this example. So we have the data types. Already mentioned that you can use all the kind of primitive or normal data types in Java, but also arrays, for example. But Flink also has a very rich type system, I would say. It also allows tuples, arbitrary type, and pojos, which are just basically your own Java object, like the edit object we showed in the example. And it's able to, via Java reflection, able to handle these custom data types very efficiently. Yes, so tuples are a very generic, lightweight, and a very well-supported data type in Flink. So you have this tuple 1 to 25, where you can store like tuple data of any type. And if you want to get data from a tuple, you just select the index of the tuple. That's also how I summed up the counts in the demo we gave, in the streaming demo. So it's just you just have to remember it starts with 0, like arrays in Java. Then there are basically 2 types of map operations. You know this kind of map operation from MapReduce, where you have an input and output type, and this typically matches. And you here, for example, you emit for every value, just emit an output. Yeah, for example, we have the 1, 2, 3, 4 input, and we just multiply it by 2, and we get this 2, 5, 6, 8 output. And you can also do that with what we call a flat map. And a flat map also receives all the inputs, but gets a collector which you can call collect on multiple times. So in this example, we just emit the number 1 time. We get the same result because we call out collect like 2 times, and would output every result twice. It's a bit more flexible. Then just another operation is the filter. Here, for example, you would implement filter function, only gets an input and returns true if you want to keep the value, and if you return false, like if it's a 3 here, then you filter out this number. So 3 wouldn't be unequal to 3, and so we filtered out the 3 in the results. Then we have groupings. So sometimes, a lot of times, we want to split, like in a word count example, our data set into groups, like based on identical keys. So if we, for example, have as input a table of names and ages of persons, you could group on the age, for example, if you want to know how many people are contained in an age group, and then reduce these groups by summing up all the counts of the people that are in the same group. So you would see that, yeah, it's obvious that there are 2 people who are 18 years old and so on. And here's the, for example, group reduce function for this example. Basically, you go over all the people who are in the same group, and you store the age group and increase the count every time you see a person, and then emits the result. Yes, so far this can be also expressed in MapReduce very easily. But we also have more complex operations with 2, for example, with 2 inputs. So typically, if we have a lot of data, we want to perform join join two types of tables like in a normal database system. So here in this example, for example, we have like a typical blog application where we have authors, and authors write posts, and we link authors and posts by assigning the author ID to every post. So we have these two data sets, and we want to join them in Flink. So what we do is we do authors join posts, and we specify the join key on the left side and on the right side. So we would specify 0 here because ID is the first field, and 2 on the right side because author ID is the third field here. And what we then get is basically a new data set which contains the results of both data sets where they were where the keys matched. So yeah, we can see here Julia's post and Romeo's post. And this is a bit bulky because you actually get a tuple 2 which contains the both types of the input data sets. But you can also use a join function, which you apply using this with syntax. And this join function, you could, for example, specify that you receive the 2 inputs, but you want only keep the name and the name of the author and the title of the post he or she wrote. Okay, so now that we got started with some basic operations, I told you already that we can specify sources and sinks, and there you can not only read from a text file but also from a CSV file, and you have this really nice way of debugging your applications by reading from a source from a collection, which is a basic Java collection like an array list. And create your data set from this, and also just specify objects with the from elements method. Yes, and the path to, for example, text file could also be an HDFS path, so we support different ways of accessing files, and it's automatically handled. Yeah, just a little example again. Not too exciting. So here we just put some strings and bootstrap a data set. Here we use an array list, which we put in here. It's fairly easy, I think. And yeah, from a file also we had this in the WordCount example, but you can also read, for example, from a CSV file. There you of course have to specify the types of your input data, otherwise Flink doesn't know how to, it's just text and Flink doesn't know how to handle it. And you can also specify to include or exclude fields via a bitmask. Basically 1 is where we include a field, a column, and 0 is where we don't. And similar for the sinks, we have write as text or formatted text and write as CSV, but we also have these special methods which in some algorithms and also for debugging are really useful. So as I mentioned, usually operations or sinks are lazy in Flink, so they are not executed unless we call execute on the environment. So all these right. If you just specify this, it will do nothing. You'd have to do an execute. But then there are the eager ones. We call them eager, which when you call print, actually, it executes and prints the results to for example, in your IDE, or you can use collect to return the actual data set. Usually it's just, the data set's just abstract concept. You can actually get it back. You can also count the number of elements in data set. Of course, you have to keep in mind that this is not always a good idea, because if you want to return a data set, you have to materialize and get it to the client. And if it's a big data set, this can take a while. It's not efficient in all cases. But if you have like a small model which you need to transfer back to the client and then submit again, then in, for example, machine learning algorithm, this is very useful. Yes, then underneath the API and the data for runtime, we have different ways of executing Flink program. There's this local execution mode, which is automatically run if you use this execution environment, get execution environment, which starts really all the process that would also run in a normal Flink cluster, but just inside one VM. And of course, it's not exactly like a real cluster, but pretty close. So if your program runs there, it's very likely it will also run in a distributed fashion. And we have, of course, the remote execution where the client submits the job to a cluster and yeah, gets results back. Yeah, if you don't want to run a dedicated Flink cluster, and because you have multiple users, you want to configure, you want to authenticate user, you want to share resources in a fair way, you would need to use Yarn, because Flink, I mean, it's not concerned too much with that because yeah, other people solve these problems and it's not so easy actually. So basically, you have a way to tell the client to use to give it a Yarn resource manager address, and the resource manager in Yarn will allocate containers which are supervised by a node manager and run, for example, the job manager, task managers there, and that makes it possible to also run it together with other applications which are supported by Yarn. Yes, and now I hope all of you are ready. Now we will proceed to do the exercises.
Any questions at this point?
Yeah.
Ah, yeah.
DataStreams, can we output the results into another Kafka in order to get another, for example, in a more complex environment? I'm going to have a Flink task, which is going, the output of which is going to be into another Flink task. So can we just output the results not into a text file, but into a Kafka?
Yeah. Yeah, we did that in the streaming example actually in the end. Maybe it was a bit quick, but yeah, we read from Kafka and then wrote back to Kafka again into a different topic. And then, of course, another Flink program could just read from this topic and process it further. Yeah.
I installed the latest version of Flink.
If they follow the instructions on this website here, it shouldn't be a problem. I mean, there are instructions on this website. If you follow them, the setup should work. But we will also be like walking around and helping you guys. Yeah, so just do this, please.
So maybe just to mention one thing, I mean, this example that you have seen now, it was written in Java. There is also equivalent in Scala for people. And also there's coming Python,
Mm-hmm.
right?
Yes.
Yeah.
Just to make, I think it is not yet out, but soon, isn't it?
Python API is already out, but it's only supported for the dataset API.
Yeah,
That's
for the
just,
data set.
yeah,
Yeah.
yeah,
Oh, that's what
definitely, yeah.
Now just browse around, look at the exercises here from overview, and everything should be covered. But we'll also like walk around now and help you guys if something comes up. So it's now almost 12 o'clock.
It's,
So we have roughly an hour left before
yeah,
lunch.
I think lunch is 12:30.
12:30. Yeah,
So we have an hour.
yeah, just get going now, and then we see how we continue after lunch. Okay? Perfect.
Mm-mm.